Hi, in this example I want to talk about how we can make a simple LC oscillator. So when you take a capacitor and connect it to an inductor, you end up creating a resonant circuit where the frequency of resonance in radians per second is equal to 1 over the square root of the inductance times the capacitance. So say you want to build a basic radio tuner. Well, that's an example of an LC oscillator. Usually your inductance would be fixed based on the properties of the inductor that you have, which is almost exclusively geometric. Now capacitance is also based on geometry, but it's based on geometry that's a lot easier to change and tune. And old school radio dials were really just capacitors where you could vary the capacitance to get a resonance at a different station's frequency. So the frequency we want to find is 97.5 megahertz, which here in Northeast Ohio means WONE. But we have a fixed inductance. We need to figure out what sort of capacitance we'd need. So to find our capacitance, we can take our natural frequency omega and solve for the capacitance. So if I square both sides, I get omega squared is equal to 1 over the inductance times the capacitance. I can multiply both sides by the capacitance and then divide both sides by my natural frequency omega. So that means then that my capacitance is going to be equal to 1 over omega squared times my inductance. And since omega, the radial frequency or angular frequency, is 2 pi times the frequency in hertz, that means that our capacitance is going to be 1 over the quantity 4 pi squared times our frequency in hertz squared times our inductance L. So now we need to figure out how much inductance we have. And we're told that we have a coil of wire that's made with 20 turns wound around a small spool that happens to be 1.5 centimeters long, a distance of 0.015 meters. And in diameter, it's only 4.5 millimeters, so 0.0045 meters in diameter. Well, that describes a solenoid. And for a solenoid, the inductance in a solenoid is equal to the permeability of free space, mu naught, times the number of turns squared divided by the length, times the area of the coils that make up our inductor. So mu naught is just 4 pi times 10 to the minus 7 Tesla meters per amp. Our number of turns is 20. We square that. We divide by the length, which is the height of the spool, 0.015 meters. And for our area, since we're given the diameter, our area is going to be pi over 4 times the diameter squared. So we calculate this out and we end up with an inductance of 5.3 times 10 to the negative 7 henries. So knowing that, I can plug that along with our frequency F into the formula for calculating our capacitance. So our capacitance would be 1 over 4 pi squared times the quantity 9.75 times 10 to the 7 hertz squared. Don't forget to square things in the denominator. And then we'd also divide by our inductance that we just calculated, 5.3 times 10 to the negative 7 henries. So when we calculate this all out, we end up needing a capacitance of 5 times 10 to the minus 12 farads, which would be 5 picofarads. Thanks for watching.